So I've been working through some different MCUs and trying to build up, schematics, circuits, I guess, and PCBs to learn about these different MCUs that I have in this list. Most recently, I guess the couple of videos I posted were on this TI TMS 320, and that seems to be going fine. And what I'm really trying to do with all this is really just to learn about these MCUs, learn about the different environments from these vendors, figure out how to better build schematics, how to better build PCBs, all of that really. Along the way, I picked up a little, time that I've invested into this Lattice ICE 40 series of FPGAs. Someone had recommended, as I was going through the MCU stuff, that this Lattice FPGA might be kind of fun to play around with, and I've been doing that, and that's been good. And so I started out with a simple QFP that was a 144-pin package and got that board up and running. I've designed a board for a 256-ball BGA, and I have recently received that in. So I am going to try to assemble that here in the coming weeks. I have before that received in a 121 ball package. So it's a BG121, and I have that board up and running. And as I'm going through all this, this is just helping me learn, I guess, how to work with, these specific packages, how to build the schematics, how to build the power for it. And that's all been really good. So, I'm looking forward to getting into this 256 BGA just to kind of see if did I do the PCB well enough that it'll run, and can I get it soldered correctly. But then I've also wanted to get into something that's a little bit different than Lattice, and I did pick up some older Xilinx FPGAs, and these are Spartan 3s. And I have ordered up a design for that, so I have a PCB that is en route right now. So this hopefully will let me, test out, take one of these FPGAs and see if I can solder it on here, and if all of the rest of the the design for one of these specific Xilinx FPGAs, if I was able to get that correct or not, and get this up and running. And so that'll be a really fun test, and that'll probably be something that I'll look at in May, probably, by the time I get around to that. But I've wanted to get maybe something further down the advancement, I guess, as far as FPGAs, and I'm going to set a pretty lofty goal for myself at this point, and this may be too much of a goal for me. I guess I'll find out. I'm hoping that I can get to this, and my goal is to get actually over to this specific FPGA from Xilinx, and more specifically, this is a SoC. So it's a Zynq-7000 SoC, which basically has an Arctic 7 FPGA equivalent in it. I've used this in the past, and where I've used it is with this board here. This is a Digilent, and it's an RDZ7, and I really had some fun working with that. And what I'd like to be able to eventually do is build my own PCB with this specific, Zynq SoC on it. And I did put in a link in here. Let me just actually refresh this. I've done some previous work on, this board here. And so if you're kind of curious, you can hit this link on my blog, and it'll take you to my YouTube, well, not my YouTube channel, but this, I guess, first of all, this blog post that has a bunch of links to my YouTube channel. Now, in this case, I was using the RDZ7-20, which again is just this board right here. And what I did is I implemented in VHDL basically my own processor, and I had previously done work with Ben Eater's 8-bit processor on a breadboard type of thing. And I really just re-implemented that instead of in hardware, with a breadboard. I built it in VHDL. And so there's a whole lot that I've got in here, but kind of what I was working on was taking this, using the HDMI output, and being able to have this processor run and visualize what it's doing as it's running, obviously with a very slow clock, kind of like you would do it with Ben Eater's breadboard. Now, these are videos before I was doing voiceovers, so it's just music, and I know some of you really dislike that, but take it for what it's worth. There's videos I kind of walk through this, and I even get down to the point where I am running some external hardware. And in my case, I eventually hook it up here. You can see I hooked this up to a VIA. So this is a versatile interface adapter that I would use in a lot of my, let's say my 6502 build or 65816 build or other builds. I use this VIA all the time. But from this FPGA, or this more specifically the SoC, I am controlling that VIA to control this 1602 LCD. And I know that's totally, relatively pointless, right? I'm using this high-end FPGA to drive a very low-end VIA and LCD. But really, it was just a really, I thought, a cool educational opportunity to build a processor in this RDZ7 and have it actually control something that I might see like in my 6502 build, and then ultimately actually have that interface with and drive an LCD. So if you're interested, you can take a look at that. If I come back up here, when this is running, I'll turn the sound off out here. I wrote a little tool that can program it and things like that, and went into the Xilinx tools and actually built. This is just getting in and showing building, really all of the pieces of that processor I built in there in VHDL and with the tool set from Xilinx. But then at the end of the day, it runs, and what you're seeing here is it basically visualizing. Maybe I can make this bigger, and I'll pause this for a second. But basically coming in here and just showing that I have this running, I have code that it's running through. I'm able to actually show you the code here, visualize it as it's running, and then as it's doing that, it's actually outputting and controlling that VIA to control the LCD. So if you've ever done Ben Eater's project, this is essentially that in VHDL, but I upped it to 16-bit instead of 8-bit. But basically this is running and showing me all of the different control bits and things like that. So really cool experience, and just helped me learn a lot about building a processor type of thing. But that link I have in this post, if you want to get it, just jumps over to this blog post that goes through a whole bunch of content, I guess, that got me from starting out with this SoC to actually doing something like that with it, and using the HDMI output for all of this stuff that you saw rendered. So what I'd love to do is be able to build my own board now that maybe could recreate some of that and then do something much better than build a 16-bit processor inside of it to drive an LCD. Obviously, there's much better ways to do that with something like this. But so I'm hoping that I could do that. And I guess this blog post that I've started, I'll continue to edit and maybe work through, what is it that I'm going to be doing here. And I'll learn as I go. I know this is going to be an iterative design. I won't get everything on the first pass through this right, or even possibly even close to right. So my goal, though, is before I order this PCB, because I imagine this will be an expensive PCB when I get to that point, I want to make sure I've done as much as I can to ensure it will be successful when I receive it and try to work with it. So if I start this process, I guess in this video, I'm going to work with this specific part right here, this part that you see right here. And so it's the XC7Z020 and then you can see the rest of that. So it's a 484 ball BGA. So that's quite a step up for me. And if I pull up the documentation for that, I can read about all the specs here, I guess, as I look at this. And let me just make this a bit bigger. But I've tried to summarize some of that here on this page. So it's a dual core Cortex A9. As far as the processor, 667 megahertz. I can see that it's got some on-chip memory. It supports DDR2 and 3. and it has an Arctic 7 FPGA logic equivalent. And then this is how many logic cells. I think this is really how Xilinx talks about the capabilities, but how many logic cells, LUTs, flip-flops, block RAM, and DSP slices. It's a 19 millimeter squared with a 0.8 millimeter pitch. So I've been doing some 0.8 millimeter pitch, so that part seems okay. But this is a pretty big package. Obviously, a lot of balls that I'll have to somehow figure out how to route. So see how many layers in a board I will need to do that. And then as far as I/O, I believe the way I understand this PS is really for the processing system, maybe more the processor I/O pins, 128 of them, and then another 200 what are called high range I/O, so anywhere from 1.2 volt to 3.3 volt for those GPIO. And I'm going to just chunk my way through this. And I think I'll just make this a video series because I think it's going to take me quite a few videos to get through this. And as I'm going through this, I will paste resources in here that I'm going to use. For example, Phil's Lab out on YouTube has all kinds of great stuff. So there's a couple of videos that I need to watch about taking a Xilinx Zynq SoC like I'm using here and connecting it up with some DDR. And so he's got a video on hardware design around this and also about getting, this DDR connected, which for me will be a challenge and is going to take me some time and effort. I've also signed up for a couple of courses on this FedEval, and when I come over here, they have these two courses that I'm kind of going through right now. So there's a mixed signal hardware design with KiCad, and then there's this advanced digital hardware design. So I think those will be really helpful. And all the stuff I've gone through so far from Philip here have been great. So far, definitely these seem like they were worth the money that I'm spending on those. And then there's all of these videos from Phil on YouTube that obviously are free that I want to work through that are related to anything related to this Xilinx Zynq and building a PCB for that. And then there's other things I'll paste in here as I go. I don't know exactly what the design is going to look like yet, but I thought I would just kind of start that up. The only thing I've started reading up on so far is power. So I thought I would start with the power setup. And I have a new project here. And so I've just created a new project in EasyEDA Pro. And I have called it, let's see here. This is FPGA dev board, Xilinx, and then the part number I'm using. And I just want to kind of get this started. And I figured over the series of videos, I'll just chunk my way through this. And I imagine in some videos, I'm going to step back and clean up something I did in a previous video that wasn't right or wasn't quite as good as it could have been, or based on feedback as I go, I'll definitely try to improve what I'm doing. So the first thing I need to do here is actually get the FPGA in this schematic, and I think there's a lot to it. So I might jump over here and go grab that part number. I'm just going to copy that. And when I go into EasyEDA, I can search for that. And they have it here, and it's offered by LCSC. And so if I was, for example, to order a populated PCB from JLC PCB, I could actually get the parts directly from LCSC. And as of right now, that part is only $17 something, which is, in my mind, that is awesome. So that's great to see. But if I place this, it comes up and you can see the size of my document here. I want to just put this off the document here for a minute. But this first thing is U?.1. And when I click, now it's going to have a .2 and a .3. So it's all of these together are part of this one IC. So 2.5, 6, 7, 8, 9, 10. And now I'm finally to a 3.1, so I'll hit escape. But all of this is what it's going to take for me to get this, this SoC, this Zynq 7000 connected up. And there's a lot here. And I'm going to try to break this up a little bit. And maybe what I'll do for now is I'm just going to make this a really big, I'll go to a D size, I guess, and just move this stuff into it for now. And I can adjust that later. I probably want to break this out, though, into maybe some different sheets. Right now I just have one sheet. It might be nice to get all of this broken up so it's not such a mess. And it looks like these three here, so 2.8, 2.9, 2.10, all of those parts have to do, it looks like, with power of some sort. Then I've got all of this over here, and I see lots of DDRs, so this must be a whole lot of stuff that I'm going to have to, at some point, figure out how to connect to actual memory. It looks like there's a bunch of MIO. And then, let's see, this is probably have to do with what I'm going to have to get to a programming header or control type of stuff, and then a bunch of banks. And so I've got a bank 13, 33, 34, 35. So I think what I'm going to do for now is just add in a new page, and I will just maybe rename this, and I'll call it power. And I think if I jump over to here, I'll grab these three parts here of it and move them over here. And I'm going to make this page a bit bigger. So let's go to maybe a C. Okay, something like that. And I need to eventually get all this power stuff hooked up here. And in this video, I'm not going to get to the point of all of this being hooked up because I still have a lot to read about what do I need for different voltages and such. Now, something else I'll point out back over on my blog post here. Some nice things out there. First of all, there is, for the RD Z7 that I've used in the past, there is a schematic that Digilent has posted, so that's helpful. I can pull that up and really see how that entire PCB was designed. So I will definitely take some guidance out of that document. And also, as I go through some of Phil's content, either in his YouTube videos or in his courses that I'm taking down here on FedEvel, that'll have a lot of guidance, I think, too, on what I'll be doing. So especially like when I get into things like the DDR, I know nothing about that at this point, and I need to learn that. And so I'll bring that in as I work on this. But I think as I get into this, and I guess just maybe even go to the RD one, this is the RD-Z7 from Digilent, and their schematic. And if I just maybe make this as big as I can here, when I scroll down through this, they have, there's the DDR3. Okay, here's power regulation. So they have a couple of sheets on power regulation, and they're using this regulator here, which is a TPS 65400. And from that, it looks like they're generating a 1.0, a 3.3, a 1.8, and a 1.5. So that's 4 voltages that I'm going to have to generate. Plus, of course, my 5 volt probably coming in to all of that. And they've got a 5 volt here that really you can supply either with a power adapter or from USB. And that's all stuff I'm going to have to figure out as I go. And like I said, that won't all get done in this video, but I'll chip away at it. I am going to maybe start with getting some type of a regulator on my board. And, they have this one here, and it's a QFN. It looks like a really nice regulator, but I'm going to try to go with an approach that's a bit easier for me to solder than QFNs. Of all the packages, QFN is my least favorite by a long shot. I like QFP. The QFP is great. Of course, doing anything with a dip, SoC, whatever, those have been all good and easy to do. But I just haven't had a lot of fun with the QFNs, and I need more practice with it, but it's not my favorite. I find it more difficult to work with. If I can do the regulators in something that's easier to solder, that would be great. And what I posted on here is maybe two things that I'm looking at for possible power. There's a regulator here. It's a PS56628. And if I click on that, that's from TI. And I'll come back to this in a second. And then I listed an alternate that is less expensive. And that is this one here. So it's alpha and omega. Maybe somewhat comparable to the TI one. And a couple of things, I guess, as I'm looking at these, I'm choosing the TI as my preferred, even though it's more expensive. And that's just because the documentation seems better with the TI. And so I think I could use the alpha and omega, save, a few dollars on the design, but probably not have as good a documentation to try to get the design right. And so I'm going to try starting out with this specific buck regulator from TI, and it is more than I probably need, and I'm going to need 4 of these so I can get all those voltages. And I'm fine taking up the space of putting 4 of these ICs on there. I don't know if that is going to make much of a difference in my design anyways, but this way maybe I'll have a 5-volt rail that goes up the side of the PCB, and then all 4 of these can tap into that, and then I'll have the inductor, capacitor, resistors that go with each, and try to lay that out in a nice way in time. But if I look at this regulator real quick, it is a buck style. It's a synchronous step down. I can feed it somewhere between 4.5 and 18 volts. So if I feed it USB-C as an example, might be the connector I use to give it 5 volts, or I might have an additional power connector or 2 that I could use. It can output up to 5.5 all the way down to 0.76. So if I go back and I look at the Digilent and I have to come up with these voltages here, that's not going to be a problem. I likely won't do any analog stuff. So the Digilent board has a bunch of analog stuff on it. I don't think I'm going to do any of their, wherever they might have it in the schematic, I guess, as far as analog. My goal is to stick more with the digital. But I think, this is going to give me way more current than I need. I think I probably want, I guess if I looked at the example from this schematic, this is a quad output, so 4 rails, and 2 of them are 4 amp capable and 2 of them are 2 amp capable. I noticed they marked them 2.6 and 1.8, but I believe when I read it, it was 4.422. I just simply picked a 6 amp and picked one that is in a package that's going to be easy for me to work with, which is this SoC 8 or 8 SoC, and they call it an H SoC, and it has this power pad, and I think that's a trademarked TI type of how they're laying that out. So they do talk about that over here, and eventually when I get down to, I suppose the footprint information, it's going to show me on PCB layout how this power pad area in the middle of that IC has to get soldered down. But I figured this is going to be easy to work with. Put 4 of these on the board. And so I'm going to jump over, and in here, I'm going to bring those in and put them on this power page. So I can add components, and that component that I want to add again is going to the top of this. I'll just copy paste this and put it in here and see if that's in the LCSC library. It is, and it shows a couple different ones. I think this is the one I want here, 50 cents. I think as I was looking at pricing, I am trying to capture this as I go in low quantities just off of DigiKey. I think those were $1.70. So we'll see, but I'll start with this here, and those look like they're the same. So I can hit place, and I'm going to have to bring out 4 of these. And maybe for now, I'll just align these like so. And then I'm going to have to work through, I've got my different parts of the schematic I'll have to put together. And let me get some of this closed up and out of the way. As I look at this design, if I come down, they give typical type of design, I believe, down here. So so here's, an example that they show. And if I want to just start building this much out, I can do that. And maybe even what I'll do back over here is I might just delete 3 of these for now and just build one of them out and then just copy and paste that whole thing. And so it looks like I've got a ground and then also this number 9. And so 5 and 9 have to go to my ground. So I'll come up here and grab a ground and get that wired up. And then I need, it looks like 3 caps that they show in this example. And I'll have to come back and do some calculations and validation later. But I'm going to put in 3 10 microfarads and a 0.1. And I'm going to do all that with 603s. So coming in here to my capacitors, let me pick the 0603. And I'll bring that out. And I said 10 microfarad. I need 2 of those and then a 0.1, and that's going to be between voltage in, which is on pin 8, and I will create a voltage in, which I'm going to just call it, let's go 5V0 as a 5 volt coming in. And so there's my 5 volt. That's going to have to get to Vn right here. Okay, so then if I keep going on this, it looks like I need an enable signal. And I think in my case, that's always going to be enabled. And, of course, I can go down through and look at, what do they show for the enable control. And in my case, I'm going to scroll up for that and just see what they have for information. It's an active high, must be pulled up to enable the device. And it seems like they've got a pull up resistor that they might be using. So I think I'll put that in for now. They're doing a 10K, I'm going to guess a 10K pull up. So I will go add a resistor and I'm going to grab 603s for that. And 10K, and that's pin 1. And that's got to get pulled up. And so this, I was just going to see if it shows a range of what I can use for voltage. And I would assume in one of these tables there should be that information. But I think I'm probably good taking that up to a 5 volt. So for now, I will just connect this up to 5 volt through a pull up. So let me get this pull up over here. So I've got this enable and let's see, input, enable. Actually, yeah, it shows this is what I was looking for. So it's showing I can go up to 18 volts for that enable. So going to the 5 volt would be perfectly fine. Okay, so in this case, they're showing, let's just start with what shows here, and we'll have to put adjustments into this later. And there's all kinds of notes and calculations and things like that. But this is an R2 and an R1, and they even give me a table. And so I might just start out and say, okay, I want to make sure I have a 3.3 volt. Let's do this first one as a 3.3 volt. And so in this case, I can see what is the value of R1, R2, and I can work that into my schematic here. So I'm going to basically come out here, VFB R1 to my voltage out. And so my voltage out on this one is going to be a 3.3 volt, let's say. And so that is VFB is going to get me to my voltage out. So let's put in a 3V3, so this will be my 3.3 volt output. And for now, I'm going to set that there because I know that's going to get me to my output. And then I need a resistor in between that and VFB. So I'll just copy and paste this one. And then the sizing of that, if I want to do a 3.3 volt, they're saying a 73.2 kilo ohm. So 73.2. And then coming back to this, there's also then an R2 going to ground off of VFB. So basically this is my voltage divider, I suppose. That's going to help me regulate the voltage correctly. For now, I'm just going to make these match as I'm going through this. It's not going to matter later, but okay, so I got R1 there, R2, and then R3. Yeah, that looks like that's all matching. And so if I look here, R2 should be 22.1K. So this will be a 22.1K. And that should be going to ground. And of course, I could just connect that over to one of these, but I'll just put another ground in there like that. Okay, so then if I'm looking at this, I have my R3, my R1, and my R2 put in, and then there's a capacitor C4, and according to this, C4 should be somewhere between 2 and 22 picofarads, so a pretty small capacitor. And maybe for now, I will just do a 10 picofarad. So far what I'm needing. Let's see, got that. Okay, now there's the, looks like this VREG and PG. And so if I look at that VREG, this is a 5.5 volt power supply output. And it says typically a 1 microfarad should be connected to ground. And over here, let's see, that would be VREG. VREG was C5, and they don't call out C5 here. So they're basically just saying that should be a 1 microfarad to ground. So I'm gonna do that 1 microfarad, and they do call that out there as 1 microfarad. And that's C5. Then I need an R4 that basically is between PG and VREG. Okay, so here I just found that they suggest somewhere between 25K and 150K, so that 100K is fine. Okay, so that is in there. Let me go back to the schematic. So VBST, it looks like that's C7, and they don't call out C7. I'm just going to put in a 0.1 microfarad between C7, or this pin 7, pin 6 is a 0.1 microfarad. Okay, there's my 0.1. Now I need an inductor coming out of the pin 6 side. So right here I need an inductor. And sizing of those inductors I know is important. And maybe for now, I will just get something in here as a placeholder. Okay, just taking a look at one of these here. This is a 3.3, 7.2 amp. Saturation, I think, is higher than I'll ever get to. And what I'm just going to look at is what's the footprint on this and see if I can get that footprint laid out. And so for now, if I look at these it's a 10 by 10 footprint, 10 by 10.2 millimeter footprint. And it looks like there's a whole series of these that I can work my way up. And maybe I just start out with a 3.3. And I think this will be sufficient. So maybe for now, I'm just going to grab one of these generically and place that. And again, I'll adjust these. And my understanding is it's better to be higher than lower than what you need. I think I shouldn't need anything higher than 3.3 in that case. If anything, I need something lower, but I'll come back to that. And that's out of pin 6. And it looks like that has to tie back over here to pin 2. And so in this case, this is my 3.3. And I might actually have this wrap around. I know that's not how they drew it, but I'm going to go like this. And then I need 2 capacitors, and they're showing a pair of 22s, which I'm sure that has to be calculated, but that would go to ground. And so let me just get a pair of 22s. I'm going to stick with this same 0603. I know I have 22s that I can use on that. So then I'm coming out of 6 through the inductor, out of 6 through the inductor. I have a pair of caps going to ground, pair of caps going to ground. Now, I should go double check. I believe, let's see, C8, C9. And they're labeling those as 8 and 9. So somewhere, let's see, if I do this, it might yell at me. No, C8, C9. And in my case, if I were doing 3.3 volts, C8 and C9 should be somewhere between 22 and 68. So that's fine. I'll just go with the 22 for now, knowing that I can always put in larger if I need to. So somewhere I am missing a C7. Let's see where their C7 is. Okay, C7 was off of pin 7. And I'm going to make mine match. And then I'm maybe missing a C6. And they must not be using the designator C6. They must have skipped it. I'm not seeing C1, 2, 3, 4, 5, 7. I don't see a C6. Okay. So then that gets me to, and maybe this flag would be better over on the right. That's going to make more sense in my head if I put this up here. Now I can copy that and have 3 more sets of these, or 2 more sets at least. And then I want to make sure I can do a, let's just see what other voltages were in this already. So there's a 3.3, I have that, and then it looks like a 1.8, 1.5, 1.0. So let's do a 1. Now with the 1.8, then we have to come back and look at this table. So 1.8, it looks like this capacitor is fine, still within that range. And even when I get to these other 2, it looks like if I was to keep that same capacitor value, I should be fine with those. It's just showing a minimum, and this is for C4, and C4 was this one here. So I was doing 10, so I'm just going to continue to do 10 for all these. And of course, when I actually am building this, I can, put on different capacitors, but for now it looks like 10 is within tolerance for all of these except for when I get to the 1.0. They're saying typically it's a 150 picofarad, so maybe I'll come down here and do a 150. And maybe I will take the 1.5. See, 1.8 is up here, 1.5. Maybe I'll take that up a little bit. And so maybe a 47. And again, I can adjust that. I don't know if that's a standard value. I think it might be 47 picofarad. Okay, so that is that adjustment. Again, going back to the 1.8. Resistors, let's see, the inductor. Oh, actually they did show typical here. I missed that earlier. So this could be a 3.3, should be a 2.2. Oops. And then when I go to the 1.8, it should be a 1.5. 1.8 is the 1.5. And then I get down to the 1.5 volt, and it should also be a 1.5. And okay, those are all 1.5. So 1.5 and 2.2 is what I need. 1.5 and 2.2. I might also end up putting in a 5 volt one. I'll have to come back to that and see if I need to do that later or not. That could be a 5th one of these, depending on if I'm taking a different power source in. But for now, I'm going to assume I have a 5 volt coming in and come back to that later. Okay, so 2.21515, and the last one was 1.5. Okay, so then I got my 2.2 and a bunch of 1.5s, so that should be fine there. And then we have the resistors. That'll be important. I had done a 73. That would be these two here, 7322. And then when I come down to this, it should be a 30.1. So they're all 22. So 30.1 instead of the 73. So 73, this then will be the 30.1. And then when I go down to the 1.5, that should be at 21.5 K. And then when I get down to the 1.0, that should be a 6.81 K. Okay, and those are all with a 22.1 K here. So I think that's all of those. These caps look like they all stayed the same. That would be over here. Leave those at the 22s. Okay, so it should be that these resistors are helping me set the voltage. It must not be a 1.2 in here. Let me just search 1.2, 1V2. So no 1V2. Okay. So then I'll have to decide later, and maybe I'll just make myself a note here. I'll put in a text box and to do and 5V regulation. Okay, so just a note for me of, am I going to need a 5 volt regulation? Now I can look at how they've done that maybe over here, or kind of see as I go through some of those online courses how that is recommended to be done. I'm sure there's something to make sure that the USB power isn't terrible, or if I come in with a different power. I believe on this Digilent they have a separate power coming in that takes a higher, like a 7 to 18 volt or something like that, in that range. Well, actually right here, 7 to 15. And so if you supply power through this, so banana connector or whatever it is, then they're going to come out and have a regulated 5 volt. And then it looks like they have a jumper. Then either you're going to pull USB power, is my guess here, or you're going to grab that regulated 5 volt. So they are throwing in a regulator there. So it might be that I want to add one more of these that brings in something higher. And maybe for now I'll put that in there. So I'm going to slide all of this down. Copy this whole thing. And in this case, I want to get a regulated 5 volt out. So I'll just call that 5V0R. And this will not be a 5 volt. Now they just called this, looks like VU coming in. And I'm not sure if that's user voltage or what the VU is, but maybe for now I would just match the name of it and call mine VU. So that is one option, is I can come in with that. And if I go back to this, then they're pulling in VCC 5V0, and that is either tied to the output of the regulator or tied to USB. So what they're going to run into all the other, or their other regulator, is the output of this. So I suppose I could just take this out. Well, I'll go like this for now. And what they did is they had that jumper. I could put a jumper in real quick. So on one side of the jumper is this regulated 5 volt, which I've got to finish out yet. And the other side would be the USB voltage, which VUSB is fine. I can call mine that. And then the output of that will be VCC. They're calling it VCC 5V0. And I'm just going to call mine 5V0. So that's my main 5 volt. And that's what will feed these other regulators. So I can either come in with some barrel connector, for example, that'll give me something that's higher, 7 volts up, 6 volts up, whatever I need for this specific regulator. That'll give me my regulated 5 volt, which will come in on one side of this jumper. The other will be whatever's coming from the USB, which I'll have to figure that out in a future video. And then you can jump between one or the other. And in this case, if you jump it to the 5V0R, that would get you to the 5V0 and feed all of these. Otherwise, it's going to come off USB. Okay, so that's good enough there for now. So let's come back here and just say if I'm looking at the 5 volt, though, what needs to change. So it looks like it's 124K for this resistor here. That stays the same. That stays with this 10-ish. So that would be my C4, which was right here. So 10 picofarad, good with that. 3.3 on this. And then I'm good with the C8, C9 there. So, okay. So this is probably where I'm going to stop today. Now, what I might do is real quick take this and convert it to a PCB. So I'm going to do an update, convert schematic to a PCB, just to kind of see what that's starting to look like for stuff I need to set up so far. And here you can see, let's see, somewhere I got a second. I must have pasted, that's U3. Do I have some leftover U2 somewhere? Okay, I've got U2, 1, 2, 3, 4, 5, 6, 7. But then for some reason, when I went over here, these jumped over to a 3. I didn't want that. So 2.7, this should be 2.8. Save that, and I'll update my schematic. Okay, got rid of that. Okay, so this is going to be my actual Zynq SoC. And then this will be all of this that I'm going to have to lay out later. So I'm not going to do that right now, but you know, kind of as a guide, I might come in here and say that I'd like to see roughly what is, oh, that's mils. Let me change that to millimeter. And I'm just going to draw a board that's 100 by 100, just so I have an idea how big is 100 by 100. And am I going to be able to squeeze whatever my design is into a 100 by 100 board? That'd be great if I could, but I can see this is getting pretty tight already. Now, I could go with maybe consolidating some of these ICs, but I don't think that's going to be the big space. I could maybe find some smaller inductors physically. That might be helpful too. But I'll have a bunch of work to do here, and it very well could be that as I get through this board, you know, it's not going to fit in 100 by 100. I would actually be kind of surprised if I could get it down to that. But maybe for now, I just go like this. And let me change the canvas origin to right there. Okay, so there's maybe a start to a board. That's going to need obviously a lot of work just to get this power stuff set up yet. But I've got something there at least to get me going. Okay, I think that's where I'm going to stop this. This is a pretty long video, so if you're still watching, thanks. And if you got any thoughts on anything I'm doing so far, I know there's stuff that as I go back and read, I'm sure I'm doing incorrectly, but this is what I have so far. Maybe in the next video, I'll keep building out and get some of this stuff here connected. I'm not really even worried about, you know, the PCB side of it yet. I might just update this kind of as I go, but that's going to require a whole lot of work at some point once I get the schematic to a decent spot. And the only thing I've got going so far on the schematic is really just trying to get these, you know, these 5 outputs here from 5 volt, 3.3, 1.8, 1.5, and the 1.0. And I've not looked at any sequencing or anything like that of do these need to come up in a certain order. So all of that is subject to change as I keep going. Thanks for watching, and if you're interested in following the rest of the series, just keep an eye out for the next video in the series. And like I said, I'm just going to chunk my way through this. Video length will probably vary from video to video, but I'll just try to hit, you know, 1 unit of work at a time and see what it takes to get through this.